Hello students, welcome back to Organic Chemistry YouTube channel. In this video, I'm going to teach you aldol condensation step by step, nothing but the mechanism of the reaction. Students, remember, whenever we write the mechanism of the reaction, it's always better to write the reaction for which you are going to write the mechanism. Here, I'm going to write the mechanism of ethanol reacting with the other ethanol in presence of a base like NaOH, it's going to form a beta-hydroxy. So this is a beta-hydroxy aldehyde, right? Which upon dehydration, right, treating with the acid at a higher condition, it's going to form an alpha-beta unsaturated aldehyde. This is the overall reaction. Now let's write the mechanism. For the aldol addition reaction as shown here, there are three steps involved in the mechanism. The first step is generation of nucleophile and then attack of nucleophile, then regeneration of the catalyst hydroxide ion. So let's see what is the generation of nucleophile first. Nucleophiles are electron-rich species. They attack the electron-deficient species like a carbonyl group. Now, the acetaldehyde molecule or ethanol, when it is treated with a base like OH minus, right, it attacks the acidic proton. Why is this acidic proton? Because when OH minus attacks this H plus and it eliminates, or when it goes as water, the formed carbanion, why is it called carbanion? Because carbon is having negative charge. Why negative charge? Because the hydrogen gives its bonding electrons to carbon and it will go as proton H plus, right? H plus OH minus will give you H2O. Now, what do we have here? A carbanion. So, coming back, why this is acidic proton or acidic hydrogen? Because the carbanion formed here is stabilized by the resonance. The carbonyl group is an electron withdrawing group. That means what? It withdraws these electrons and makes it stable like this. So, let me erase this water, right? So what we are going to get here is a stabilized structure. It won't stay like this forever. Again, the electrons will revert. That means what? The negative charge is on carbon and it is being stabilized by the carbonyl. That's why the alpha hydrogens are considered as acidic. Let me repeat this once again. The hydrogen present on the alpha carbon are considered as acidic, but they will not be as acidic as the carboxylic acids. Okay, their acidity is less, but in presence of OH minus, the OH minus attacks the hydrogen, then it forms a carbanion, which is a nucleophile, and it is stabilized by the resonance. That is the driving force here. And this is also the rate determining step because it is the slowest step in the reactions. Why is it slowest step? Because the carbon hydrogen bond, which is considered as stable, has to break here, right? That's the reason this is also called as rate determining step. Now let's see the second step, that is attack of nucleophile. The formed nucleophile, whatever we have, it should attack something. What it should attack? It should attack the other aldehyde molecule. What is the other aldehyde here? It's a ethanol or acetaldehyde molecule. Whenever you write the reactions or reaction mechanism, always make a habit of telling the names of the molecules so that you will remember the names. Okay. So now look at this. This is a nucleophile. It will attack the carbonyl carbon. Why so? This carbon is partially positive and this oxygen is partially negative due to the electronegativity of oxygen. So when it attacks here, oxygen takes. That is the driving force here. And how do you write the product? This is a crucial step because there is a carbon-carbon bond formation. And how do you write this? Look at this. Oxygen is taking away the electron. You move the hydrogen over here, okay, so that it will be easy for you to write the structure of the product form like this, like this. Okay, since this is not stable, usually it will revert like this. That's why the overall reaction is a reversible reaction. Okay, so now the negative charge is on oxygen. So finally, you have to regenerate the catalyst OH minus. What does that mean? You take this oxide ion and then you treat this with water. You don't have to treat, the water is already there, right? So it's going to pick up the proton. See how it happens? Oxygen takes the hydrogen, hydrogen gives the electron to oxygen. So that means what? You are going to get your alcohol like this. OH and the H is as it is, and then CH2COH. What is happening to this one? It's becoming OH minus. So you have regenerated the catalyst. And look at the nature of this final product. It is beta-hydroxy. Why is it beta-hydroxy? If this is a functional group, this is alpha, this is beta. Beta-hydroxy aldehyde. You can even give the UPAC name for the product formed here. So there are two functional groups. There is an alcohol and aldehyde. Aldehyde is a principal functional group. That means you have to number from here. 1, 2, 3, 4. At third position, there is a hydroxyl group. Therefore, how do you name this? 3-hydroxy. 3-hydroxy, and it's aldehyde with 4 carbons. So butanal. Butanal. So this is how you convert ethanol to 3-hydroxybutanol. Where is a new bond formed here between carbon and carbon? This is the mechanism of the aldol addition reaction, where a molecule is added to the other molecule. That means out of two aldehydes, one act as a nucleophile. This is a nucleophile. And where is the electrophile? This is the electrophile. And then we are going to get a addition product. Now let's see the simple dehydration of 3-hydroxybutanol to but-2-enal. Since the reaction is done in acidic medium, the hydroxyl group of the beta-hydroxyaldehyde will get protonated. What does that mean? You see that there is a lone pair of electron present on the oxygen of the hydroxyl, which is going to pick up the proton. So it's going to attack the proton. Then what happens? Oxygen will become trivalent. We know oxygen is divalent. When it is trivalent, there will be charge on the oxygen. Now, what should happen is that we have to ultimately remove the water. So, this step will be single step. How it will happen? Oxygen carries the bonding electrons here, and then at the same time, we are going to regenerate the catalyst also like this. So, that means what? This will leave as H plus. This as water. So, what we are going to get now? You see, there is a double bond. A pi bond is being formed like this. What about this? The H plus is regenerated, whatever the H plus is used, and it is always in a forward direction because the reaction is done at a high temperature. So what we are going to get here is a alpha beta unsaturated aldehyde, or simply you can call this as, there are 4 carbons, right? Therefore but. At what position the double bond is there? Second position, 2-in-1-al, or simply but-2-enal or 2-butanal. Either way it is correct. Now that you have learned the mechanism of the reaction, it will be easy for you to write the aldol addition product and aldol condensation product in one step. So in my next video, I'm going to take few examples and teach you how to write the structure of the products. Thank you for watching this video. Until next time.